The hidden maths that keeps buildings standing, or how structural engineers actually think. It's about making buildings stand up. Our introduction, structural engineering is not about making structures strong. It is about making them safe, efficient and predictable. Every beam, column and foundation exists because an engineer has calculated two forces how forces move through a structure. This lecture explains how structural engineers think. And step 1, we understand the structure and its purpose. A structural engineer begins by asking what loads will act on the structure. How long must it last? What are the consequences of failure? A bridge, a house and a stadium all carry loads, but the acceptable risk is very different. And in step 2, identify loads. Loads are classified carefully. Common structural loads include dead loads, self-weight, live loads, people, vehicles, etc. Wind loads, snow loads, seismic loads. Engineers assume worst case realistic scenarios, not the average ones. In step 3, understanding load paths. Forces must always travel somewhere. A structural engineer traces roof loads to beams, beams to columns, columns to foundations, foundations to the ground. If a load path is unclear, the structure is unsafe. Nothing floats in a building. Step 4, simplify the structure into elements. Real structures are simplified into beams, columns, slabs and trusses. Each element has no mathematical behavior. Simplifications allow calculation while preserving safety. Step 5, bending, shear and axial forces. Structural members experience bending, causing tension and compression, shear, sliding forces, axial forces, which are pushing or pulling. Engineers calculate internal forces before choosing materials or sizes. This step is non-negotiable. And step 6, stress, strain and material behavior. Forces alone are not enough. Engineers calculate stress equals force divided by area. Strain equals changing length divided by original length. Materials behave differently. Steel yields, concrete cracks, timber creeps over time. Structural design respects these realities. And step 7, safety factors and codes. Structures are never designed to just hold. Engineers apply partial safety factors, load combinations, design codes. This ensures safety despite material variability, construction errors, unexpected loading. Codes are not restrictions, they are accumulated experience. And step 8, serviceability matters too. A structure can be safe but unusable. Structural engineers also check for deflection, vibration and cracking. People notice movement long before collapse. Good engineers consider comfort as well as strength. Step 9, failure, modes and redundancy. Engineers ask, how can this fail? Does failure spread or stop? Good structures fail gradually, not suddenly. Redundancy saves lives. The big idea, structural engineering is controlled force flow. Engineers do not fight forces, they guide them safely to the ground. Why this matters to employers? This thinking prevents a catastrophic failure, saves material and cost, produces safe, elegant structures, reflects professional responsibility. Structural engineers protect lives. A conclusion, a building stands because an engineer has traced every force inside it. Equations make this possible. Judgment makes it safe. And that's the conclusion of this short lecture.